Hi everyone. So in this video we'll be starting with the questions on binary search. So first one would be like to calculate the upper bound and lower bound. And I hope you guys are coming from my part 1 and part 2 video of binary search, because from there I'll be using many concepts, mostly that L and H, how this L and H move. So let's see directly what the question says. Okay. So first thing is the question asks to find the smallest value which is greater than K. Okay, let's say target is 7. Okay, k is your 7. So smallest value greater than 7, obviously you can get the idea, which is 8 here. Okay, now what I say, so obviously this is a binary search problem. Why? Because the first thing is you can go with order of n, like linear traversal plus the array is sorted. So this thing, and at the same time what you can see here, that you can divide the search space into two parts, which greater than k, where is your, like where you can say your favorable and like favorable zone, and lesser than equals to k, it is your unfavorable zone. Why? Because the question says itself that you want to find the value, the smallest value greater than k. So your answer will always lie in greater than k region. Okay, so let's divide this search space: unfavorable, 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 favorable, favorable, and favorable. Okay, and so here we'll be starting with binary search. Okay, so L and H. Now if you remember guys from a part 2 video, what I said, first of all see this, so what is your answer in this as space when you're done with, like when you convert this array into this part? Forget about this array for now. Okay, forget about this array. So which is your answer? Obviously your answer is first element of second space, just this, like this is your first space, this is your second space, like second set, you can say. Your answer is your answer, what is your answer? Your answer is first element of second space. Okay, now if you remember guys, so what happens when your binary search is about to terminate, like, or you terminate, sorry, when your binary search ends, what is the uh, what is the placings of L and H? If you remember from my part 2 video, L, this L will be at first index of second space, like here. H will be at last index, last value of first space, here. So and what you want, you want your answer of first index, first element of second space. So who will give your answer? Either your L index will give you answer, or H plus 1 index will give you answer. That's it. It is as simple as that, guys. Now let's see directly and write our binary search. So what I say, while L is less than equals to H, calculate your mid first. Okay, so what is your mid? You can calculate mid like this, first thing. Then remember guys, if you are at favorable, where would you move? Would you move to right or left? Obviously you cannot move to right. Why? Because you want the first favorable. Here you'll be getting the last ones. And what is favorable? Remember guys, you don't draw this array. How you divided the search space? Whenever in my binary search, you write if these conditions, if and else, you, these if and else's will divide them. So if a of mid is greater than k, all these regions are what? Favorable. If they're greater than k, all these regions are favorable. And in favorable zone, what you have to do? You will do h of mid minus 1. So h equals to mid minus 1. Else, what you have to do? Else is L equals to mid plus 1. Obviously, if you are at unfavorable zone, where you have to move, you cannot move to left anyways, because if you want to find the first favorable, so you have to move to right. Now when it is done, what you have to return? Finally, when it is done, when it is finished, okay, you have to return what? You can return L or H plus 1. That is your choice. Now listen guys, there is one I can say corner case, and in which, let's say that you are given element 1, 2, 4, 5. Okay, and you are given k equals to 6. You are given k equals to 6. Index is 0, 1, 2, 3. Here if you see, there is no element greater than 6. There is no element greater than 6. So in this condition, what you have to return? You have to return the final index plus 1, which is the length of this array. So you have to return 4. You have to return 4, because there is no element greater than 6 up to this 3, up to 0 to 3 index. You have to return 4. Now see guys, if you see this carefully, so where your L is, let's say here, L is here. Okay, and obviously H will be at final index. Now, if you remember, guys, if you remember what I said earlier in part 2 and even here, that when your binary search will be terminating where your h will be, h will, because all these are unfavorable zones, okay, because they are lesser than k, all these are unfavorable zones. So when your binary search will be terminating, your h will be at last position, last value of first space. So here if you see how we are dividing, first we are dividing unfavorables, then we are dividing favorables. So h is already at unfavorable, which is h is already at last position of first space. So h will not move any further, like any left. Why? Because to move h, you can also think that to move h, it should land at where? It should land in favorable, but there is no favorable. Now only L will move. And where L will move? You know, L will move just right to H when your loop was terminating, which is L is less than H. Okay, sorry, L is greater than H, and which we also say how, like first element of second space. Here there is no second space, so obviously L will cross 3. L will move to index number 4. L will move to index number 4, which is not existing by the way, but L will move to 4. Like L will point to index number 4, and then where your loop will be ended. And here also, see guys, L will give you answer, L or H plus 1. Okay, so you see how you like, if you saw that video carefully, part 2 video, your L and H concept will be clear, and that will directly help you this. Look, I have not changed the binary first template here. Now let's see for this thing, greater than equal to, okay, again. So coming from the coming from the upper bound, so greater than equal to k, I'll say them favorable this time. Earlier what I said, greater than k only, and lesser than k, I'll say them unfavorables. So let's say k equals to, I take 6. I take 6. So lesser than are unfavorables, but greater than equal to are favorables. Greater than equal to are favorables. Okay, and what you want? First element of last space you want. First element of last space you want. That's it. So if you draw this here, forget about this. Now you remember L and H. L will point at this, H will point at this. So again you have to return either L or H plus 1. So if you write again, the binary search will not be that different. Calculate mid. You know how to calculate mid. That's L plus H minus L by 2. This time if A of mid is greater than equal to, earlier it was greater than, it is now greater than equal to k. In that way what you'll do, you'll move your H to mid minus 1. Okay, everything is same guys, everything is same, so I'm not repeating that. Everything is same, and when it is ended, after like this while loop, just return what? Return L. That's it, return L.